All right, so our next bit is dot product with the notion of parallel and perpendicular. And so our first little example is this. I'm going to work through a few examples here. So vector v is negative 4I plus j. Vector w is 8I minus 2j. And we want to find the measure of the angle between them. So we want to find theta, the angle between v and w. All right? So we know cosine theta is v dot w divided by the product of the magnitudes. The cosine of the angle between two vectors is the dot product divided by the product of the magnitudes. It's the dot product divided by the product of the magnitudes. So, in this case, that is, I need the dot product of the vectors. So, multiply the two first components, multiply the two second components, and then we need the product of the magnitudes. Magnitude number 1, negative 4 squared plus 1 squared, square root of this, the second is 8 squared plus negative 2 squared, square root of all that. So I have negative 32 plus negative 2 over, I have the square root of 16 plus 1, and I have 64 plus 4. That's equal to negative 32 plus negative 2, negative 34 over the square root of 17 times the square root of 68. Now you can simplify this several different ways. The most straightforward is just take a calculator and work that out. We know that from our property before, we know that 17 times 68 is 1156. And that works out to be, if you work this with a calculator, that works out to be negative 1. It probably shouldn't be too surprising that if this weird, long, involved computation works out to be some special little number, that something special is going on, and that, in fact, is what's happening here. Because what we have now is cosine theta is equal to negative 1. So that implies that theta is cosine inverse of negative 1. Take the cosine inverse of both sides of this equation, cosine inverse of both sides of the equation, and cosine inverse of negative 1 in degree measure is 180 degrees. What that means is these two vectors are opposite each other. They are parallel. They're parallel to each other. They're just in the opposite direction. If we could try to draw a reasonably decent picture, so negative 4, comma 1, and 8, comma negative 2. Now my picture is terrible, but at least that leads us to believe that this is not an unreasonable result. And in fact, this is correct. The angle between these vectors is 180 degrees, which is to say they go in opposite direction. They are opposite vectors. They are parallel. So the two vectors are parallel. If this computation, the dot product divided by the product of the magnitudes, if that works out to be negative 1, then cosine inverse is equal to 180 degrees. Now, suppose this computation works out to be positive 1. Now, it didn't in this case, but suppose we have different vectors, and work. This works out to be positive 1. Then theta is cosine inverse of positive 1, and that becomes 0 degrees. So those vectors are in the same direction, it's just possibly of different magnitudes. And so in that case, the vectors are parallel. So here, vector v and vector w are parallel. In this scenario, any scenario of this nature where the cosine theta works out to be 1, vector v is parallel to vector w. So vectors can be parallel, and that is found by taking the dot product divided by the product of the magnitudes and computing cosine inverse. If that works out to be 0 degrees or 180 degrees, then the vectors are parallel. Now, we did an example in the previous video where this next piece works out. But suppose we have vector v is 3I plus 2j. Vector w is 6I minus 9j. And the question is, can we find the angle between them? Well, we know cosine theta is equal to the dot product over the product of the magnitudes. Dot product over the product of the magnitudes. Dot product is 3 times 6, 2 times negative 9, and then we have the magnitude, 3 squared plus 2 squared, and we have 6 squared plus negative 9 squared. Well, what do we have out of all that? That becomes 18 plus negative 18 over, and it turns out, it doesn't matter what this is, as long as it's non-zero. This is 9 plus 4 is the square root of 13. This is 36 plus 81, which is 117. So what do we get out of all that computation? Zero over, and 13 times 117 for the record. It doesn't matter, but 13 times 117 is 1521. Because that's 0. And this happened in an example in the previous video. What we have is, so cosine theta is equal to 0. So theta is cosine inverse of 0, which is 90 degrees. These vectors are perpendicular. A slightly different terminology we use for vectors is orthogonal. Orthogonal is typically the language we use when we talk about vectors that are perpendicular. Typically, we don't use perpendicular with vectors. Typically, we use the word orthogonal. For our purposes, they mean the same thing. They're not quite exactly the same, but for our purposes, they are. So two vectors are orthogonal if their dot product is equal to 0. Is it clear? As long as this numerator is equal to 0, then the value of the denominator, as long as it's non-zero, is irrelevant, because 0 divided by any positive number is going to give you 0. And so this computation will work out to be 0. These vectors will be orthogonal anytime this numerator works out to be 0. And so we have the following statement: V and W are orthogonal if and only if the dot product is equal to 0. Vectors are orthogonal if and only if the dot product is equal to 0. Now what that means is this: if you're on the road of doing this computation and you see the numerator works out to be 0, then you may stop doing the denominator. Now the only way the denominator could equal 0 is if one or the other of these is equal to 0. The only way that could happen is if one or the other of these original vectors is the 0 vector. But remember that we are, when we talk about angle between vectors, we are eliminating the 0 vector to start with. So the upshot of that is this denominator can never be 0. It must always be positive. So the only way this fraction can equal 0 is if the numerator is equal to 0. That is to say, the only way that the vectors can be orthogonal, work out to have a 90-degree angle between them, is if and only if the dot product is equal to 0. Here's the upshot of that. If you're doing this computation and you find the numerator to be 0, then you may stop doing the denominator. That value is equal to 0. They are orthogonal, and that's the end of the problem. So, parallel is if the angle between them is 0 or 180 degrees. Perpendicular, no, we're going to say orthogonal. Vectors are orthogonal if the angle between them is 90, and that requires, orthogonal is equivalent to saying that the dot product is equal to 0. Vectors are orthogonal if and only if the dot product is equal to 0.